Good morning everyone. Today I will discuss about electromagnetic radiations continued to the yesterday's class. See, the electromagnetic waves. Electromagnetic waves means the waves which are having both electric field and magnetic field. Both are propagates in perpendicular to each other. The waves are formed by both electric field and magnetic field are known as electromagnetic radiations. The example for electromagnetic radiations: X-rays, gamma rays, UV rays, TV rays and radio waves. And now to explain electromagnetic radiations, here some parameters are required. That parameters are known as wavelength, frequency, velocity, wave number and amplitude. About the first one is wavelength. Listen, one is wavelength. That is wavelength represented by lambda. See, everyone must observe the wavelength represented by lambda. So wavelength means, what is wavelength? So for example, take this is wave formed like this. See, here the height of the wave is known as crest. The depth of the wave is known as trough. Troughs. The depth, it is known as trough, that is known as crest. See, here it is also crest. It is trough. Now, what is wave? Wave means, for example, take from this and this, the distance between two successive crests, the distance between the two successive crests, see, like this is known as wavelength, or two successive troughs, it is known as wavelength. So here the wavelength means it is the distance between the troughs and crest. So here, so distance, what are the units of distance? Generally a small distance always indicated by centimeters. For example, long distance indicated by kilometers, and less distance indicated by meters, and very less distance indicated by centimeters, and very less distance indicated by angstroms, nanometers and picometers. So it is very small distance wave is known as wavelength. Indicates always the distance between two successive crests or two successive troughs. So means the distance is very small. So hence, if you want to explain that, it is must be take angstroms. The units of wavelength, angstroms. The units of wavelength, nanometers. The units of wavelength, picometers. 1 angstrom is equal to 10 power minus 10 meters. 1 angstrom is equal to 10 power minus 8 centimeters. 1 nanometer is equal to 10 power minus 9 meters or 10 power minus 7 centimeter. 1 picometer is equal to 10 power minus 12 meters or 10 power minus 10 centimeters. See, if you take in centimeters, the values are also given, and meters are also, values are given in here only. Okay. Now if you take, what is the relation between picometers and angstroms? For example, if you take 1 angstrom is equal to 10 power minus 10 meters. 1 picometer is equal to 10 power minus 12 meters. Therefore, the relation between angstroms by picometer, take like this. Then it is 10 power minus 10 and 10 power minus 12 meters. Then 1 angstrom is equal to 10 power minus 10 multiple with 10 power 12 by 1 pm. Then it is 10 square. See, 1 angstrom is equal to 10 square picometers. Means 1 angstrom always equal to 100 picometers. 1 angstrom always equal to 100 picometers. See, generally, so 1 angstrom is equal to 10 power minus 10 meters means it is very small distance. Hence, waves always occupies very small distance. Due to this, they are explained in angstroms, picometers and nanometers. This is about wavelength. Understood? Wavelength means it is the distance between two successive crests or two successive troughs. Crest means the height of the wave is known as crest. This is known as total. Above the axis, the wave is known as crest. Below the axis, the wave is known as trough. Understood? This is about wavelength. Okay. And now the second one is frequency. Second. Frequency is represented by nu. Nu. N-E-U. Nu. Frequencies represents nu. So, what is a frequency? It is frequency means, for example, take, this is the starting point of wave. Wave moves like this. Okay. Now, from here to here, take 1 meter length. 1 meter length. Okay. See here, number of waves crossed 1 meter length in 1 second. It is known as its frequency. Frequencies depends on distance and time. Hence, we will calculate the relation between frequency nu is equal to c by lambda. It is inversely proportional to lambda. If wavelength increased, then frequency is decreased. The wavelength increased means frequency is decreased. The wavelength decreased means frequency increased. So, in starting, its frequency is more. After reaching more distance, then frequency always decreases. So, here the frequency is nu is equal to c by lambda is the formula, where c is known as velocity of light. Velocity of light. And it is always constant. It is 3 into 10 power 8 meters per second, or 3 into 10 power 10 centimeters per second. Okay. And already we know lambda is known as wavelength. So, what are the units of frequency? The units of frequency, that is units of mu is, it is centimeters per second. Take velocity is meters per second, wavelength take meters, meter cancel. then unit is 1 by second, or it is known as second inverse. Second inverse must be it is hedge. The units of frequency hertz or cycle per second or second inverse. These are known as units of frequency. Now another term is, it is 3, wave number. See, wave number is represent nu bar, wave number. That simple definition for wave number, the reciprocal of wavelength is known as wave number. In wave, the reciprocal means take, that is nu bar is equal to 1 by lambda. It is known as wave number. Nu bar is equal to 1 by lambda. The reciprocal of wavelength is known as wave number. Or number of waves present in fixed point in unit time is also known as wave number. The number of waves present in fixed point in unit time, it is also known as wave number. So wave number nu bar is equal to 1 by lambda. Based on this, we can, what are the units? Units are meter inverse, because it is 1 by meter inverse, or centimeter inverse. So or angstrom inverse. See, like this. These are the units of wave number. Now if you take here, will related to this wave number to frequency. Generally we know nu bar. So what is frequency? Nu is equal to c by lambda. Then 1 by lambda is known as, that is nu by c. So instead of 1 by lambda, we can put here nu bar is equal to nu by c. Nu bar is equal to nu by c, because 1 by lambda is equal to nu by c. Then we can take nu bar, nu is equal to c into nu bar. Nu is equal to nu into c into nu bar. So frequency is directly proportional to wave number. The frequency is directly proportional wave number. This is about wave number. The wave number means the reciprocal of wavelength is known as wave number. The reciprocal of wavelength is known as wave number. And the last one is known as amplitude. Amplitude. In the case of amplitude, that is, in the case of amplitude, what is amplitude means? For example, take wave like this. So here this height of crest, the height of crest, or this depth of trough is known as amplitude. The height of crest or depth of trough. See, what is the use of amplitude? See, the amplitude gives the intensity of the wave. If amplitude is more, intensity is more. If amplitude is more, intensity is more. So here if you observe this, in the starting point of the light or any radiation, they moves like this in starting point. See, amplitude is more. On moving like this, amplitude decreases. See, like this, amplitude decreases. So this is starting point. See, starting point of the light, intensity is more. Why intensity is more at the initial point of the light? Because amplitude is more. So amplitude is directly proportional to intensity of wave. This is very important point. So what are the units? Amplitude also height, that is length. The units of amplitude is meters or centimeters or angstroms. These are the units of amplitude. Understood or not? So today class discussed in related to the parameters of the electromagnetic radiation, like wavelength, wave number, frequency and amplitude. These are related to the electromagnetic radiations. Tomorrow class I will explain, that is characteristics of electromagnetic radiations, and also explain the numericals in electromagnetic radiations. Understood? Okay, today's class over. Thank you. Good day. Tomorrow I will continue.